Welcome to the solutions to homework set number 1 for ECE 111. The first set of problems are using Matlab to find the roots to a polynomial. Now Matlab is a really powerful program. Think of it like a high-powered calculator. One of the things it can do is, given a polynomial, it'll tell you the roots. The way Matlab does it is Matlab is a matrix language. If I want to input a polynomial like this, it actually is input as a matrix. The reason for that is polynomials are hard to program, but matrices are really easy. So Matlab uses a matrix to represent a polynomial. In this case, decreasing powers of s would be the numbers. So this would be 1x cubed minus 9x squared minus 49x plus 441. If I then find out what are the roots of that polynomial, again, this matrix represents a polynomial, it tells you the answer. This has roots at minus 7, plus 9, and plus 7. Second example, this polynomial would be 1x to the fourth, 0x cubes, 85x squared, minus 60x plus 864. Find the roots to that polynomial, and here's your answers. And finally, if you have a fifth order polynomial, I have 6 terms here. Again, each one represents the coefficient in decreasing powers of x. Find the roots, and here's what you get. Roots could be real, could be complex. That's problem 1. Problem 2 is Matlab will also multiply out polynomials. In this case, I would represent the roots of a polynomial as a matrix. Again, kind of like the answers here, this was stored in a matrix. I'll input the matrix. I have a root at 0, at plus 10, minus 7, and plus 7. If I then say, what's the polynomial that has those roots? I get this. And what it means is, again, decreasing powers of x. 1x to the fourth, minus 10x cubed, minus 49x squared, plus 490x, plus 0. Or a second example, if I have the roots being minus 9, minus 1, plus 4, plus 6, plus 9, plus 10, find the polynomial that has those roots, and you get this. And again, that represents decreasing powers of x. So that's the first two problems. Problem 3 is how to solve two equations and two unknowns. One way to do that is to plot them. If I let x go from minus 4 to plus 4, steps of 0.01, that's what this notation does. It's just a quick way to type in a whole bunch of numbers. Constant spacing on the numbers is pretty common in Matlab, so they provide you with an option for that. That'd be this notation. The first function, call that y1, call that y2. y1 is sine of x divided by x squared plus 1. And here, I need to use the dot notation. Again, Matlab is a matrix language. If I do slash, it'll try to do a matrix division. I don't want it to do that. I want to do element by element division. X is just a column of numbers. I want to do each entry like it's a separate calculation. That's what the dot notation does. y2 is cosine of x. Plot x versus y1, x versus y2, and that's what you get. Where they intersect, those are your solutions. So here, there's actually two solutions between minus 4 and plus 4. Roughly, it's minus 1.7.21 and plus 1.2.4. Again, kind of hard to read off the graph, but that's roughly where they are. In homework set 2, we'll look at how to calculate that more precisely. Another example, if I have two equations, two unknowns, sweep x between minus 4 and plus 4, steps of 0.01. y1 is 1/4 e to the x over 2. y2 is sine of 2x. Plot the two together, and you get this. And where they intersect are your solutions. In this case, there are 4 solutions. And reading off the graph, I get roughly what they are. Again, in homework set 2, we'll find these more precisely. So that's one of the beauties of Matlab. It has really good graphics as well. With Matlab, you can also do for loops. You can write little have loops in your system. For a loop where that's useful is something like this. I have two teams playing a game. In any given game, A's got a 25% chance of winning, 30% chance of a tie, 45% chance of a loss. So what I could do is when I do rand, this function right here, that's a number between 0 and 1. If rand is less than 0.25, I won, plus 1 point. There's a 30% chance of a tie, so I take this one, plus 30 is 0.55, and the remainder is a loss. So what I'm going to do is play a single game. I'll pick a random number and then check. Did I win, tie, or lose? On a win, I'll add a point. Tie, I'll get half a point. It's like a baseball score, and no points for a loss. Repeat 5 times. That's the for loop. When I do that, A is going to be a number between 0 and 5. How many wins they had? If I wind up at 2.5, or bigger than 2.5, that was a win. At 2.5, that was a tie. Otherwise, it was a loss. That's an if-then-else statement. So that'd be for a single match. Repeat 100,000 times. That's what this does. That for and that end. This is called a Monte Carlo simulation. If I can play the game once, I can play it 100,000 times and keep track of how many times I win, how many times I tie, how many times I lose. This is in 100,000 games, so roughly, there's about a 15.5% chance of winning, 16.8% chance of a tie, and 67% chance of a loss. This is another beauty Matlab. This is actually a rather hard problem to solve. In this 5-game series, what's the chance of a win, given these win, ties, and loss probabilities? With Matlab, I don't really have to calculate it. If I can program a single game, I can program 100,000 games, just with a for loop. And the probability is roughly how many times a win out of 100,000. That's a Monte Carlo simulation. A slightly different problem is a while loop. Suppose you have to play until somebody's up by 2 games. That's a little bit different. In that case, the way I'm going to score is on a win, I get plus 1 point, on a tie 0, on a loss, I get minus 1 point. I'm going to look, as soon as I get to plus 2, the game's over, I won, or minus 2, the game's over, I lost. Somebody has to get to plus 2 or minus 2. That's a while loop. Keep on playing until you get to 2. So if I win, then lose, win, then lose, that's a wash. I got to keep playing until I win. That'd be for a single match. If I can play a single match, I can play 100,000 matches. And after every given match, I'll check, am I at plus 2? In that case, it's a win, or minus 2. It's a loss. And the net result is 16% chance of a win, 83% chance of a loss. Again, that's a rather hard one to calculate, but again, the beauty of Matlab is if I can play a single match, I can do a Monte Carlo and play 100,000 matches and get the odds. Problem 7 is Gauss's dilemma. This is kind of a famous problem in statistics. In theory, the winning should be infinite. The way the game is played is I put $20 in the pot, or cost $20 to play, and the pot starts at $1. I'm going to flip a coin. If I get a tails, rand is less than 0.5, I'll double the pot. Keep doubling the pot until I get a heads, then I kick out. When I kick out, the game is over. I collect the pot minus the $20 to play. Now in theory, the winnings are infinite because I have a half chance of winning $1, plus a fourth chance of winning $2, plus an eighth chance of winning $4, and so on. Add them all up, I get a half, plus a half, plus a half, plus a half, out to infinity. The expected winnings are infinity. So based upon the expected winnings, I really want to play this game. So let's try it. If I play this game 100,000 times, if I play the game 1,000 times, after 1,000 games, I'm down $15,000, $14,000, down $12,000, up 1,000, down 14,000. Basically, it's a really lousy game. In practice, you almost always lose. I'm always losing around $12,000 to $15,000 in 1,000 games, even though on paper I should win infinite. That's why it's called Gauss's dilemma. It's a game where no casino is going to offer it because expected winnings are infinite, but no one's going to play it because everybody keeps losing. Occasionally somebody gets lucky and wins, but usually you lose. This is kind of a cute sidelight. Another thing Matlab is good for, you can roll dice. So one way to do that is this would be a 4-sided die, 6-sided, and 8-sided die. What rand of 1, 3 does is it generates 3 random numbers between 0 and 1, times 4 gives you 3 random numbers between 0 and 4. Stealing is round up, so this will be numbers between 1 and 4. So I get 3 random numbers between 1 and 4, 4 random numbers between 1 and 6, 5 random numbers between 1 and 8. Those are my die rolls. My output is just the sum of all the die rolls. One way to see what the distribution looks like is create a dummy variable called result, just a bunch of zeros, and then fill them in. If I got a 13, I'll increase the result of 13 by 1. If I got a 22, increase the result of 22 by 1. Repeat 100,000 times, and then look at how many times I rolled each number. That's a bar chart. Bar chart looks like this. So this is the frequency, how many times I rolled each number. And if you notice, it's a nice bell-shaped curve. We're going to see that over and over again. This is called a normal distribution, probably one of the most important distributions in all statistics. You keep seeing it over and over again. But that's kind of a sidelight. We'll see that again later. If I want to know what's the probability of rolling a 50, I can just say, what is result of 50? And divide by the number of times I roll the dice, about 4.08%. So there's roughly a 4% chance of rolling a 50. What's the chance of rolling more than 50? I want to take all these, add them up. That'd be sum. Sum the result between 50 and 76, divided by how many times I rolled the dice, 19% chance. Again, these are kind of hard to calculate, but that's the beauty of Monte Carlo. If I can play the game once, I can play it 100,000 times, and that'll tell me roughly what the odds are. A really powerful tool that you can do with Matlab. And the last one is kind of similar. Suppose I have 2 people playing a game. A rolls the dice from problem 8, 3 4-sided dice, 4 6-sided dice, 5 8-sided dice. B rolls 2 100-sided dice. Add them all up, whoever has the highest total win. Who are you going to bet on? Well, offhand, I don't know, so I'm going to use Matlab to determine that. I'll first play a single game. I roll the dice. A is the sum of the 4, 6, and 8-sided dice. B is the sum of 100-sided dice, and then check. If A is greater than B, I won. If A is equal to B, I tied. A less than B, I lost. And kind of note, in Matlab, each F statement has to terminate with an N statement. And you can add the carriage return, it's not necessary. Carriage returns are just for the programmer. Also, for equals, double equals is compare, single equals is assign. So this is assign the number 0 to W. This is compare, A to B. A and B stay unchanged, I just compare, true or false. If I can play a single game, play 100,000 games. And then check how many times I won, tied, and lost, divided by the total number of games I played. That gives you probability. So A has about a 9% chance of winning, 0.4% chance of a tie, 90.3% chance of losing. So if I were to bet, I would put my money on B. So that is homework set number 1. Again, the point of this class is how to use Matlab. If the homework is kind of confusing or you're getting kind of stuck, a good place to go would be the old homework sets and solutions. The homework sets for each semester are kind of similar. Same course, same lectures, same material. I changed the numbers, so don't just submit last semester's homework. But that kind of gives you an idea where to start. And hopefully by the end of the semester, Matlab will be a little bit more be a little bit more proficient with Matlab. The goal of the course is when you get to Circuits 1, Circuits 2, you're ready to use MATLAB. You're not learning MATLAB at the same time you're using circuits. So again, the first couple assignments I expect you to be kind of struggling. That's why we have recitation. Hopefully later on, you'll get more of the hang of it, and these assignments will be fairly easy for you. Again, homework set number 1 for ECE 111.